Okay, I'm good to go?
Perfect. Right on time.
Good. The recording is already
exactly
started.
what I wanted to say, that the recording continues.
Okay.
Even the break and everything.
Okay, perfect.
So we can start.
Good. Audio is on here. You can hear me? Yes?
Yes.
Okay. Well, welcome to the session. My name is Alessandro Pilotti, CEO at Cloudbase Solutions. We're going to talk about OpenStack, Kubernetes, and Windows, how these three things work together, right? Most of them, you want enterprise world, especially here in Europe, comes from a Windows stack. How many of you guys have Windows workloads? How many of you guys are using OpenStack? Okay. How many of you are using Kubernetes? How many of you are using these three things together? That's what I was trying. So far, if you want, Windows, Kubernetes, and OpenStack are three independent silos. Okay? So people just see them as completely independent. On the OpenStack side, if you want, is a bit of the proprietary software versus open source device, which is slowly coming together. The Kubernetes, because it's simply dependent. Right? So what we are helping typically as company, our customers do, is to bring this work together and moving, if you want, from traditional virtualization like VMware and so on, to the ready world, so infrastructure as a service, all the open source, Kubernetes. So we're going to talk a little bit about the technological challenges, what we did, how that works. Okay. Let's start with Windows VMs in OpenStack. Okay. Windows VMs in OpenStack means you take a Windows VM, either you deploy it natively in OpenStack or you move it from your VMware or existing on-premise environment, and you make it run in OpenStack together with your workload, right? Usually people come to me and say, why? Is that even possible? Well, of course it's possible for a few reasons. The first one is that the operating system itself works well in a virtualized environment. The second is that with all the work that we did starting already in 2012 in the OpenStack space, Windows is a first-class citizen exactly like Linux. So spinning up a Linux VM or a Windows VM from an OpenStack standpoint makes no difference. For libvirt and KVM, it's always better to specify the right time. This is a setting, so we should specify it. This is the Windows one, so we get a little bit a bit of a different series of settings at the job level, at the QEMU level with KVM, okay? And you have to sysprep images for Windows support. Another important thing is that in a virtual environment, you have virtual hardware, typically virtualized and so on. In case of Hyper-V, you don't need to install anything, so Windows will just work out of the box. In the case of KVM, for example, you need to install the VirtIO driver, which opens an interesting box with about which of the virtual drivers you should install. Okay. I get there. In case of you using, of course, OpenStack with the ESXi of this sphere, then you need the VMware tools, or it can serve the security, of course. The next important thing is Cloudbase-Init. Whenever a virtual machine, or even a bare metal one, if you want to start in a cloud, it needs to fetch information from the cloud about what that machine is supposed to do. For example, network configuration, for example, users and passwords, OpenSSPs or X509 user data scripts that need to be executed, workload and prepared. So this is done with interacting with the metadata services that the specific cloud provides. Individual clouds have their way of providing metadata. OpenStack, of course, is some metadata service, which is more for the EC2 from Amazon. Okay. So the idea is that in the VM itself, you need to have an agent which starts when the machine gets provisioned, fetches this data, typically either via HTTP or from a local attached ISO or similar, reads the content and applies it. Okay. It's not mandatory. You can still have your VM without that, but then you have to know username and password, the machine will be completely isolated from the cloud. You will have the APG automation. In the case of Linux, this agent is called Cloudbase-Init. In the case of Windows, it's called Cloudbase-Init. Any of you are already familiar with Cloudbase-Init? Oh, good. Fully open source tool, of course. We wrote it back in the day, starting in 2013. We have some basic telemetry that comes with updates and everything, which tells us that the usage of those things already passed 200 million VMs being booted on all over the world. Of course, we don't know who did that per se, but we know that there is a lot of usage out there. So whenever people say, "Oh, OpenStack is dying and everything," I would say definitely not, because those numbers are from people running stuff in production. It's not marketing hype, it's actually running stuff, and it keeps on increasing. So the reason for that is pretty simple. OpenStack passed the hype period, and it's a production thing. When people use stuff in production, they don't make much noise around it. It just works. Right? So, and that's very, very important for us, and it's, I think, for the entire ecosystem. It works. You can provision, of course, Windows images wherever you want, whatever hypervisor. As I mentioned before, fully open source, 100% Python code. We wrote it in Python, but first because we started in 2013 with this project, so there was still no Rust around. Today, I would probably be writing in Rust. Okay, but back in the day, Python was definitely the right thing. Also because DevOps can easily get into that, modify it, changing, report bugs. So we have a very healthy ecosystem of people coming back with support requests, info, log tracks, and everything. It supports a lot of clouds. OpenStack, EC2, Azure Stack, CloudStack, OpenNebula, Mass, GC, Oracle Cloud, and so on. And by the way, in Oracle Cloud, every single Windows instance that you boot in an Oracle Cloud has Cloudbase-Init installed. Okay. So it's basically the default de facto standard for everything which is cloud related and Windows. Okay, here I have a bunch of features that Cloudbase-Init does. Might be useful to know because people might say, okay, I have a Windows image running, I have my VM running in a cloud. Why do I need extra provisioning? Well, there are a ton of things, and this is just actually a partial list. First thing, you might want to set a hostname, otherwise you get a random name when the machine boots. And the hostname, of course, matches the name that you pass in when you boot the VM. So you find it with a name in the OpenStack API, and you find it with the same name. So. Well, users and passwords. You might want to, of course, inject your own users, and even the administrator needs to have its own password. I will explain also later how this happens without passing any password in clear text around it. Static networking. Not everybody uses the HTTP. So Cloudbase-Init fetches the information about static networking, including also VLANs, bonding, and so on. And all this stuff gets fetched and applied. Public keys. So SSH public keys and X59 public keys gets also fetched and installed locally. Okay, deploy locally. Why you want to have X59 and SSH keys in Windows, you might say? Well, there is an OpenSSH server available. And also, that's one of the features that we contribute to OpenStack, you can also have X59 keys, which are basically certificates, which you can use to have passwordless login in Windows as well. Very important. Automatic volume expansion. So when the VM boots, typically the image is the minimum. And then you attach, for example, a boot volume, which is, I don't know, 100 gigs. So somebody has to expand the file system, such as the partition and the file system to this 100 gigs, right? So that's something that, of course, the provisioning agent does for you. Otherwise, something you have to log in, and this part, WinRM HTTPS listeners. And if you use Ansible, for example, yes. Ansible is famously an agentless, provisioning tool. So, in the case of Linux, it connects to SSH. In the case of Windows, it connects to WinRM. For simplicity, for now, consider WinRM as a SSH point. Okay? It's not, but just to give an idea. So, in order to do that, you have to first configure the machine to use WinRM, especially over HTTPS. Cloudbase-Init does it for you. Otherwise, you have first to go to the machine, If you look at the Ansible documentation that tell you how to configure that on the Windows machines, you don't have to do it. Cloudbase-Init does it. The moment you use centric boot, you already have it. You just add a security group which allows you to access the machine with the right port, which is 596, and voila, you have it. So Ansible works out of blocks. Time series. You might want to make sure that your VM is using the time service, the entity server that comes in via the metadata service. Actually, in OpenStack doesn't come with the metadata service, comes via an ECP option. So Cloudbase-Init is also leading the specific ECP options in a private block. What else? Automatic updates. Your machine needs to be updated. So Cloudbase-Init can configure that for you. Some policy, okay, that is needed what to do when you attach an extra volume, because by default the volume doesn't do anything. So you need to attach it, mount it, so it's visible. Licensing. Especially if you move machines around, they need to be licensed. Which means that there are various ways of licensing Windows VM. This is a Linux, unfortunately, so you have to deal with that. Cloudbase-Init can do that for you. Applying license keys, setting the right SKU, and everything. NTP, mentioned before. MTU, that's also important. The MTU comes in via the HTTP option, and especially if you use like OBS, you set the wrong MTU, no networking. As soon as a packet goes out, which is bigger than the MTU, nothing. So this way, Cloudbase-Init is also capable to set the right MTU that comes in from the cloud, and so all your data is optimized for the data traffic you have. Last but definitely not least, is user data. You can run whatever script you want, typically PowerShell, but we support also Python and other things. Okay? Even support Bash. The user data can be a simple script, which is compatible with the format and also Amazon users for AWS, but it's basically similar to the way in which user data scripts work in Linux. The difference is that the first line is not cbank, setting Bash or whatever. It's like simply GTS1. Okay, so #, this one. That actually instructs Cloudbase-Init to say, hey, that's a PowerShell script. And it simply executes whatever you want it. And that helps you installing, I don't know, SQL Server, SharePoint, Exchange, whatever you want. Plus allows also things like heat templates. If you use heat templates, then you have the full automation, meaning at the point that you can do really whatever you want, right? Next, well, more details, you can see there in the documentation. Yes, the slides will be available also to the OpenInfra Days site, so you can access them, and if not, of course, feel free to get in touch with me for any information. Cloudbase-Init gets used by a very large number of companies and users worldwide, so CI testing is extremely important. So Cloudbase-Init gets tested regularly on every possible cloud and on every possible supported Windows version, okay, including 2019, which I forgot to add over there. All right. Next, what happens if somebody wants to try Windows images in a cloud? So somebody doesn't have necessarily Windows experience and wants to actually try out how Windows works in an OpenStack cloud. Well, thanks to an agreement with Microsoft, we can distribute Windows images already prepared for OpenStack, which means Cloudbase-Init installed in the virtual driver area. Only for trial purposes, okay? So Microsoft gave us a specific license that somebody has to accept before being able to download, okay? So that's the only limitation. So no usage in production. People always find it very, very useful for that. Okay, let's say that you want to build your images for Windows images for OpenStack. We provide a bunch of open source scripts which are available at that repository over there. They are in PowerShell, so you just run those PowerShell and they create images for you. Of course, you have to provide an ISO that comes with the volume licensing or whatever else, and it automatically produces. Includes VirtIO, Windows updates, custom driver, custom apps, and all. Here are some user data examples, as I said before. The only thing you have to do, first line PS1, and also we are compatible with the Amazon format, which has that funky XML size tag PowerShell field function. You can see that. some basic examples, how to create users, how to do a domain join, an offline domain join. And next, the heat templates, as I mentioned before. You guys familiar with heat templates? Raise your hands who uses heat templates. Very good. So full support for that, and we have also a bunch of examples in the upstream repositories, like how to deploy an Active Directory controller, how to deploy SQL Server, and so on. And we have also more complex one, like full SharePoint, full SQL Server, full Exchange, with multiple machines. So licensing, everybody's favorite topic. Windows licensing is one of the things that unfortunately we have to deal with, especially if you come from a Linux background, it sounds like it's something extra. But if you're used, for example, to Red Hat, you're already used to the fact that machines need to be registered, right? So it's nothing necessarily new. We recommend typically our customers to use data center licenses because they allow you to have unlimited virtualization rights. What does it mean? You get one license for the host, and you can have as many VMs as you want on that specific host. So if you have an OpenStack cloud, for example, you might want to have a bunch of nodes dedicated to Windows. Running KVM or Hyper-V doesn't really matter what they run, but you have just to make sure that your host aggregates whatever. When the Windows machine starts, gets deployed on those nodes, and you provide licenses on those nodes. As simple as that, right? And the other nodes could run Linux. Otherwise, you have to provide data. So wherever there is a Windows VM running, that VM needs to be licensed. Either individually, which I wouldn't recommend unless you have just a few of them, or at the host level, which is definitely less expensive, okay? It boils down to something like, it depends on your density, but we did some math and like with a density of around from 70 to 100 roughly VMs per host, okay, you get down to like $2 to $5 per VM per month. So it's not such a big problem. People used to think that they have to shell out a lot of bucks, for Windows licensing, but it's not like this if you plan things properly. Does Microsoft support Windows VMs in OpenStack, or even solutions that are providing OpenStack-based compute with Windows? There is a project or a program called SVVP. So if you run Hyper-V, no problem. You're already supported, okay, out of the box. If you run anything else, like KVM and everything, your vendor needs to be part of the SVVP program. Of course, Canonical, SUSE, Red Hat, and so on are all there, okay? But if you deploy your own upstream, let's say Kubernetes, with the open source VirtIO drivers, then you don't have it. So you got some people are fine with that. They say, well, we never use support. But others say, well, we need to be compliant with our company policies and we use support. That's one of the many reasons why I recommend people to use Hyper-V nodes for OpenStack. Does Microsoft support Hyper-V in OpenStack? Yes. More specifically, more precisely, they support Hyper-V, they don't support OpenStack. Right? So OpenStack is supported by whoever deploys. Us in our case, or the company itself, if it's a self-provision node or whatever vendor, right? But Hyper-V itself, since we use only documented APIs, okay, Hyper-V itself is fully supported by Microsoft. So if there is a bug, let's say in Hyper-V, Microsoft supports it. We have, of course, from a community standpoint, a direct engagement with the Hyper-V team and everything, but also from a vendor standpoint or from a customer standpoint, if there is a bug in Hyper-V that comes out in an OpenStack scenario, that's fully supported. Okay. I'm going to go briefly on top of Hyper-V. Unfortunately, these sessions are only half an hour. It's not a lightning session, which is 15 minutes. It's also not a 45 minutes. We have to be very attentive in how much content we put. So OpenStack on Hyper-V is probably the best option you can have for running OpenStack. Does it require System Center? No, luckily no. We don't like System Center in the context of OpenStack, and it doesn't really make sense to have it because all the features that you need are already baked in Hyper-V itself. What do you have more with Hyper-V that you don't have with KVM? You have failover clustering, very important for enterprise customers because when they move typically the workloads from traditional virtualization into OpenStack, they don't get really along with the capital system, right? So the idea that if the host dies, the VM dies, doesn't really fly very well in enterprise world. Especially when you're used to the Windows clustering, when you're used to the VMware, vMotion and everything, that when a node dies automatically moves everything to a running node. Well, we bridge the two worlds. So you can have Windows failover clustering with Hyper-V together with all the tools from OpenStack. You don't have that with KVM. Remote effects for VDI, shielded VMs, better performance, so there is a lot. So, we have a lot of partners, SUSE, Canonical, Red Hat, they're all certified solutions. Okay? And we have our own, of course, Hyper-V-based OpenStack distro that we call Hyper-C. It's fully based on the latest and greatest Windows Server features and storage spaces direct and so on. Again, going a bit quickly on top of these topics, and if you have any questions, just feel free to ask. One question that very often arises is like, which version of Windows should you use? Because things became a bit more complicated lately. We recommend, if you have a fast deployment cycle, to go with the 6-month releases that Microsoft adopts. So every 6 months, typically a new version comes out. No? But those versions typically have limited support, while periodically a long-term support comes out. For example, the latest long-term is 2019. The previous one was 2016. So depending on how long your workloads need to run, you might want to stay on the latest and greatest, or stay with a long-term. Okay, next. Networking. When we started on this work with OpenStack, we knew that if we just added Hyper-V nodes to existing clusters, well, those machines would have been completely isolated unless we spoke a specific lingua franca for networking to talk also to the KVM node. And that's why from the early days we started porting OpenStack. So we ported also OVS to Windows, and now we have also OVS support that we also use for Kubernetes. How many of you guys use OpenStack? Good. Just a quick note on this. There is a new project called RASVMN, which we are working with, which is meant to make a very, very lightweight VMN, okay, Windows machine manager, okay, on top of the hypervisor. So replacing QEMU and all those things with an extremely lightweight one. It's basically the work that Amazon did starting with Firecracker at the community level. It's also endorsed and used actually by Kata containers. WHP is the Windows hypervisor platform that allows you to do that. I just mentioned here because in case any of you guys is interested in the RASVMN work, I would be happy to talk to you about that. Okay. Last few minutes, I will dedicate that to Kubernetes. Kubernetes on Windows. So when VMs were the big thing until a few years ago. Then containers came out. Then it took some time, of course, to find a common, of course, or standard, de facto standard container orchestration, right? And Kubernetes became that. So we started working with Microsoft and with other companies like Apprenda and now VMware in all the porting. It became beta 1.9 and become a production-ready release with 1.8. So you can have Windows nodes in your Kubernetes cluster. The big difference, if you want, compared to the OpenStack story, is that in OpenStack you can run Windows VMs on KVM, on Hyper-V, on VMware, whatever else, right? In the Kubernetes world and the container world in general, Windows containers run on Windows, period. You cannot run a Windows container on Linux. Okay, you can run a Windows container in a Windows VM on top of Linux, and that's a different story. The machine which is actually running, the host which is running the containers, is the Windows. So we have now the possibility to have a mixed node, so your master will still run on Linux, and your compute node will be a mixture of Linux and Windows. So kubelet, kubectl, and so on will run on Windows, master and API still on Linux. There is a lot of work going on on the networking side, on the storage side, and so on. Long story short, there is a seed called seed Windows where we do that work, but as I mentioned before, it's production ready and it works there. Here is a quick diagram about how the Kubernetes of Windows works with OBS and OVN. And I think we got to the demo. Let's see. Well, I think we are 14:14, so we are at the last possible moment. Do you guys have any questions? I think the only thing I can do in such a short time is spinning up again, assuming that the VPN works. So just to show you here, this is actually an OpenStack environment running entirely on Hyper-V nodes. And you can see here a bunch of hosts. For example, you have a Kubernetes minion, which is running on Windows, and a Kubernetes master, which is running on Linux. We are here. Check if my environment works. Okay. So, this is my master. I'm just connected to the master right now. I will just spin up quickly a deployment. Which contains, everybody likes YAML when it comes to Kubernetes. Contains a very simple IaaS, so basically the web server from Microsoft. The image is Microsoft IaaS. Okay? It's basically just a tiny Windows image dedicated to running IaaS. So my goal right now is just to show you that it's actually a Windows container. Actually two containers, two pods, micro sizes, if you have two replicas, running on Windows nodes. So if I get my pods right now, I have two pods running, which are Windows. Okay? Now if I expose that guy, I'm using a node port in this case. So my ports again, let's say the services. And if I curl on that, voila, this is IaaS answering now. Okay? So this is a super quick demo. Again, we have half an hour. I could demo this thing for hours, but I have to leave it my time. So, any questions before I go? Okay, thank you guys for joining.